So in today's class we are going to learn structures. Okay, so let me share the screen and let's start with a simple example. Okay, so let's open a file called employee structure. So what is a structure? Till now we have learned variables like integer, float, double and all those things. Okay, so structure basically consists of multiple different types of variables. Okay, structure is a collection of different types of variables. So let's take an example. So let's assume that I want to build an employee database. Okay, so an employee will have multiple different attributes like employee id, employee name, employee age, employee salary, etc. Right, so all these things I can combine in the form of an employee structure. All right, and then I can make different variables of that structure. Like employee 1 will have different ID, name, age, and salary. Employee 2 will have different ID, name, age, and salary, and in this. Okay. So let's suppose I want to build an employee structure which consists of 4 different attributes: ID, name, age, and salary. So how can I do so? I can write struct employee. You will see that struct is a keyword. Okay. Employee is the name of the structure. And all the different attributes of employee you can write inside these curly braces. Okay. So for example, in my case, the attributes are employee ID, employee name, employee age, and say salary. So let's make the age short. So then we will have 4 different types of variables or 4 different types of attributes that are part of the employee structure. Okay, and then you can write different employee variables or this kind of these structured variables like structure. Okay, so structured employee, say E1. Suppose there are 5 employees. Okay, E2, E3, E4. All right. Okay, so let's learn some terminology. So this is called structure definition. This is the definition of employee structure. Okay, this is called structure definition. Okay. And this is called structure declaration. Okay, clear to everyone? Okay, later on we are going to see some other ways of definition and declaration or how to combine them and all those things. Okay, for the timing, let's start with this simple syntaxes. Clear? Okay, so let's run it quickly and see whether it is giving any trouble or not. Okay. So you need to put a semicolon at that. Okay. All right, so there is no syntax error and run here. So let's proceed. Okay, so I have defined a structure, I have declared the structure variables. All right, the next thing is how I can initialize the structure variables. Okay, all right. By the way, these are called structure members or structure elements. All right. Okay, so suppose I want to initialize the structure variables. So the one way of initializing it by using the dot notation. So let's see. Suppose I can write e1 dot age equal to say 40. Suppose I am writing e1 dot age equal to 40. That means the age of employee e1 will be initialized to 40. Clear? Using the dot operator. Clear? Similarly, e1 dot name will hold the name of the employee 1. Okay. So as name is a string, I cannot write e1 dot name equal to something. I need to use the string function called string copy. Okay, string copy e1 dot name. Say and delete. All right. So in case of string, if you want to write or if you want to initialize some string, you need to use string copy, the name of the string and whatever string you want to initialize. Okay. So string copy destination source. All right. It will be copied from source to the destination. All right. So whenever I'm using string function, I need to include the header file string dot h. Yeah. Similarly, I can initialize e1 dot. So I will initialize a before. So id equal to say 1, 2, 3, 4, 5. e1 dot age equal to 40, and then e1 dot salary $1,000.576. All right. So in this way, I can initialize the structure variables. So this is called structure initialization. Okay, clear to everyone? So let's see whether the initialization is successful or not by printing it. So the employee named person is with ID person B is person B years old and get a salary of person B. So person S will be replaced by first e1 dot name. ID is going to be replaced by e1 dot ID. Age will be replaced by e1 dot age, and salary will be replaced by e1 dot salary. So let's run it. The employee named Angelina with ID this is 40 years old and I get a salary of this. Okay. So we have defined, declared, initialized, and printed the structure elements properly. Okay, structure elements corresponding to employee 1 correctly. Clear? Okay. Now let's. That is a different way of initializing the structure members. Okay. So let's see another way for employee 2. So suppose I want to initialize the structure elements corresponding to employee 2. Okay. So I can initialize all the different structure members one after other inside the curly braces separated by comma. Okay. So for example, I can write that the ID of employee 2 is say 2, 3, 4, 5, 6. The name is say Carol. The age is 35. The salary is 4,000. All right. And I need to do a type definition by writing struct employee before it. Okay. So this means e1.id will be equal to this. Sorry, e2.id will be equal to this. e2.name will be equal to Carol. e2.age will be equal to 35. e2.salary salary will be equal to 4,000.678. Yeah. So let's see whether this is also working perfectly or not. So here I just need to replace E1 by so the employee named Carol will I with ID this is 35 years old and get a salary of this. Okay, clear to everyone? Okay, now let's see. So now suppose the salary of say E2 is incremented by say $500. Okay, how can I have initialized the structure elements. Now let's see how can I change the structure elements. Okay. So let's see that the salary of E2 employee 2 is incremented by $500. So you can write E2 dot salary equal to E2 dot salary plus 500. That means salary of E2 is incremented by $400. And then you can print the new salary of E2 is percent. So the new salary of E2 is 4,500.67800. Alright. Okay. You can also do structure assignment. For example, you can write E3 equal to E2. Okay. That means whatever attributes of E2 will be copied to E3. Alright. So you can also do structure assignment. But you cannot compare structure directly. Okay. So let's see. So suppose you want to compare E2 and E3, whether they are same or not. If you write if E2 is equal to E3, that will give a trouble. So let's see. So suppose I want to compare E2 and E3. So if E2 equal to E3, I am writing printf the employees same as they are different. So if you compare E2 and E3 like this, then it will give an error. Okay, because structure variables cannot be compared directly. Okay, you cannot compare structure variables in this way. Okay. You can assign one structure variable to another structure variable, but you cannot compare it. Okay, so you cannot write if E2 equal to E3 or E2 not equal to E3, something like this. Okay, so to compare two structures, you need to compare each and every structure elements. Okay, you need to compare each and every attributes of E1, E2, and E3 separately. So for example, if you want to compare whether they're equal or not, you need to compare if E2 dot ID is equal to E3 dot ID and E2 dot name. So I cannot write E2 dot name equal to E3 dot name because it's a string. So I need to use string comparison or string compare. E2 dot name, E3 dot name. Okay. String compare. This function will compare two different strings. So basically, this function takes the difference of two strings. Okay. If the difference is 0, that means they are equal. If these two strings are equal, the difference is 0, otherwise difference is going to be non-stop. Okay. So if ID is identical and name is identical and age is identical and salary is identical, then the employees are same. So now it will work. The employees are same. Okay, clear to everyone? If I change something, say employee 3's age has been incremented to 1, incremented by 1, then we are going to be different. Okay, so in this way you can compare two structured variables. Okay, you cannot directly compare two structured variables, rather corresponding to each and every variables you need to compare the structure members. Okay, clear to everyone? So you can assign one structured variable to another structured variable directly, but you cannot compare them directly. You need to compare each and every structured elements and members separately. All right. Okay. Now let's see. So here in this example, I have first defined the structure employee, and then I have declared the structure variables. All right. Now I can do both of these two things together. Okay. So for example, I can, let me just comment this out. So instead of writing declaration and definition and declaration separately, I can directly write the definition, and then here I can write E1, E2, E3. So here I am declaring, I am defining the structure and declaring the structure variable together. Okay. So this is basically called structure definition plus declaration. Okay. And I have defined the structure, and then I have declared the structure variables too. Okay. So this should also work perfectly. Clear? Okay. Second point is that, so let's go back to the previous syntax where I was declaring and defining them separately. So here, as you can see that I need to write struct employee again and again. Okay. If I want to get rid of this struct part, okay, then I need to do a type definition. Okay. So let's see how can I do so. So I can write type there struct, and then I can add the elements. Okay, and then here I can write employee. All right. So from this point onwards, I can simply ignore the struct keyword. Okay. So let's see. This will also work as it is. Okay, clear to everyone? So by using type definition, I do not need to use the word keyword struct again and again before imply. Okay. So these are different ways you can define and declare a structure and then the initialization using dot operator, assignment, and comparison will work as it is. Okay. So the next, I want to show you how to use a structure inside another structure. Okay. So let's take an example. So here I'm going to take the same example and then I'm going to expand it. Okay, let's take the employee structure. So hash include. Okay, let's take this employee structure and then let's modify. Okay, so here my employee has an attributes ID, name, age, and salary. Okay, and let's assume that we have 5 employees. So instead of declaring E1, E2, E3, E4, E5, I'm just declaring in the form of an array. Okay, you can also declare the structure variable in the form of an array. E0 is going to be the first employee, E1, E2, E3. All right. Okay. Now, suppose I want to, add some more attributes, but I am going to use the concept of structure inside structure. Okay. So suppose I want to add the contact numbers of the employees. Okay. But there will be 2 contact numbers. Say one contact number will be corresponding to the landline, another contact number will be correspond to the mobile. Okay. So how can I add it? I can write struct and inside the struct I can write type. So the type can be landline or mobile, right? And then the number I am using for number I am using long because number can be separate digits long. All right, and there can be 2 contact 1, contact type 2. Okay, so contact 1 may have a type like landline or mobile and the number. Contact 2 will have a type like landline and mobile. All right. So corresponding to each and every employee, I am adding 2 types of contacts. So this is an example of structure inside another structure. Okay, clear to everyone? Okay. So let's initialize all the attributes. So let me take the previous example and then elaborate. So the first 4 attributes is easy to initialize. Right? We have already done it before. Next, suppose I want to initialize contact 1 and contact 2. So how can I do so? I can write. Okay. So here previously I have used E1. Now I am using the array notation. So E1 needs to be replaced by E0. All right. Okay. Now let's see. So suppose I want to initialize contact 1 corresponding to employee 0. So I can write E0 dot contact 1 dot type. Okay. E0 dot contact 1 dot type. Now type is a string, so I need to use string copy. So string copy, this is a landline and the contact 1 number is E0 dot contact 1 dot number equal to say 1, 2, 3, 4, 5, 6, 7, 8, something. So this is the way you can initialize the uh, structured elements. All right. So inside this structure, maybe you can declare another structure. So you need to use u0 dot contact one dot type dot something. Okay. All right. Now for contact two also you can write e1 dot e0 dot contact two dot type is say mobile, and e0 dot contact two dot number is say 4567890 something like that. Okay. So let's see. The employee person S as a person S number person LB and person S number person LB. So e0 dot name e0 dot contact one dot name e0 dot contact one dot number e0 dot contact two dot name e0 dot contact two dot number. Basically, it is going to print the employee Angelina has a landline number this and mobile number this. All right. So let's, and here I have used the string function. So I need to include string.h. Let's compile. So number. No, sorry, this is type. Okay. So the employee Angelina has a landline number this and mobile number this. Okay. Okay. So let's move on. So let me discuss some details of how to access structure members. Okay. So I have already shown you how to access structure members using the dot notation. Right? But let's see that how we can use some other notations that are related to pointers. Okay. So by using pointers, how can we access the structure events? So let's learn something more about accessing structure elements. Okay. All right. So suppose I want to say make a structure called birthday, okay, corresponding to different employees. Okay. So struct birthday corresponding to different employees, and the structure elements are say the day, month, and year. Okay. And let's say there are 3 employees. So E1, E2, E3. Right? Okay. So how can we access the structure elements? we have already learned that using the dot notation, you can access the structure elements. For example, you can write e1 dot day equal to 5, e1 dot year equal to 2000. Okay. Similarly, you can write e1 dot month. All right. I'm sure not showing it. Okay. Now, suppose I want to declare a pointer to a structure. All right. So I can do it by writing struct birthday asterisk ptr. That means ptr is a pointer to birthday. Okay, ptr becomes a pointer to a birthday. And now I can write ptr equal to ampersand e1. All right, that means ptr becomes a pointer to the structure in the structure variable e1. Okay, ptr becomes the pointer to the structure variable e1. Okay. Now let's see how can I access the structure event using ptr. Okay, all right. So this becomes say e1 is basically the variable e1 dot day, e1 dot month, e1 dot year, and ptr is a pointer to that structure variable. Okay, all right. So using the pointers, if I want to access the structure elements, there are two notations that can be used. One is by using indirection notation, another one by using the selection notation. Okay, so let's learn indirection notation. So using indirection notation, you can write asterisk ptr dot day equal to 5. Okay, or you can write asterisk ptr dot year equal to 2000. Okay, clear to everyone? This is about indirection notation. Otherwise, you can also use selection notation. Selection notation or selection operator. Okay, indirection operator, selection operator. So using the selection operator, you can write ptr arrow day equal to 5, ptr arrow year equal to 2000. Okay, clear to everyone? So these are the two operators. By using these two operators, you can access the structure element through the pointers. So whenever you are going to play with pointers and structure, I'm going to show you one or two examples in a minute. Okay, whenever you are going to play with all these things, whenever you want to pass something to a function, pass a structure to a function, and you want to make sure that the change that you are making in the function will get reflected, then you need to use either indirection notation or selection notation. Okay, so let's take an example. Close this. So let me open a file called function. Okay, so let's reuse the same example. All right, that is birthday. say let's use type def. Type def struct, and here I will have day 1 and say birthday is the structure. Okay, and then I am writing birthday corresponding to 10 employees. I'm just using the array notation. All right. Okay. Now I want to write a function. As we have learned selection and indirection notation, I want to use it by passing the structure variables to functions and make some changes over there. Okay, so let's write a function that is going to take the pointer to structure variable E0. Okay, E0, E1, E2, E3, all these are structure variables. So let's write a function that is going to take a pointer to this structure variable E0, and then we'll record the date, month, and year. I mean birthday, month, and year corresponding to E0 from the user. Basically, it is going to scan the date, birthday from the user. Okay, so let's write a function. Say take birthday. It is going to take the birthday from the user, and here I need to pass the pointer to the structure variable. Okay, I need to pass the pointer to the structure variable. Clear? So this function will take the pointer, and then from the user, it is going to ask the user that enter the birthday. The user will enter the day, month, and year. So it is going to store it corresponding to E0.day, E0.month, and E0.year. Clear? So let's how can I do so? So this function doesn't return anything. Void birthday. So this is the address of variable E0. Okay. So to store the address, you need a pointer to birthday. Okay. All right. So here it is going to ask the user to enter the birthday. And the user is going to enter the day first. So which will be stored in, let's use the indirection operator. The indirection operator, how can I store it? Asterisk case dot day, right? And ampersand before this. Okay. Is this clear? So I have shown you that asterisk s dot day. Using this, you can access the structure element. Okay. For using scanf, you need to use ampersand before it. All right. Okay. So similarly, let's do the same for the other structure members. Month and year. All right. And whenever I will come out of this function, as I have called the function using the pointers, the change should be reflected whenever I'm going to come back. Okay. So let's see whether the change is indeed reflected or not by calling another function to print it. So this is also going to return void. Let's say print. birthday. So we can directly print the birthday is percent d slash percent d slash percent d. I'm printing in day, month, and year. Okay.
Yeah.
All right. So asterisk s dot month s dot year. So this is kind of the syntax. Okay. If there's any syntactical error, I'm going to come, find it when I will compile. So let's declare the function prototype. All right. So here my skeleton of this program is prepared. I have declared the birthday structure. I have defined the birthday structure. I have declared the variables, and then I have passed the pointer to the one of the variable to this function where I have changed the value, or I have taken the values from the user, and then here I have also sent the pointer to one structure variable, and here I have printed it. Okay. So one of the problem here is that whenever you are writing birthday asterisk s, there is no definition of birthday outside main, because I have defined birthday inside main, right? Since in this function, birthday has no meaning because I didn't define birthday outside the main function. So what we need to do, I basically need to define the birthday. In this case, I need to define the birthday outside main. Okay, clear to everyone? If I define it inside main, then in this line and in this line, the compiler will not able to understand what is birthday. Clear? Because birthday was defined inside main function. Okay. So if I compile it, let's see whether it is giving any trouble. So let's see. I missed a semicolon. Check. But okay. So enter the birthday, say 5th December year 2000. So the birthday is 5th December year 2000. Okay. So here I can see that I can successfully pass a pointer to a structure variable, modified it, and then here also I have successfully passed the structure variable, and I have seen that whatever change I have made over here is getting reflected. Clear? Okay. So this is about indirection operator. Okay. I can use selection operator also. Okay. So for example, instead of writing asterisk s dot month, asterisk s dot day, I can simply write s arrow month. Okay. As we have seen that both are identical. Instead of printing asterisk s dot year, I can write s arrow year. Okay. This will also give the same thing. So 10th October, say 2015. 10th October 2015. Okay. So any of these two notation you can use. All right. Now let's see how can I use how can I find the size of a structure. Okay, it is little bit complicated, so uh, let's try to understand this here. Size of structure. Okay, so let's learn how to calculate the size of a structure. It's a little bit complicated. Okay, all right. So let's write a structure called say random. Okay, we're going to take some random values, and let's see there are three members: int x, int y, and all right. Now, if I print, or let me declare the structure variables r1, r2. Now, if I print the size of r1 is percent ld size of, okay. So if I run it, it is going to show you that size of r1 is 12 bytes. Okay, but this is not that simple. Okay? In this case, all three structured elements are of type integer. That's how it is coming as 12 bytes. Okay. Let's see that one is a char, another is a short. So what will be the size of R1? So ideally the size of R1 is should have been size of an integer, which is 4, plus size of a short, which is 2, plus size of a char, which is 1. So 4 plus 2 plus 1 is 6. Okay, so if I run, it's going to show you as 8 instead of 7. So let's see what's happening. Okay. In fact, if I add another, okay, let's start with this example. Okay. So instead of 7, you are getting 8 byte. All right. So there are two important rules that you need to remember while calculating the size of a structure. Okay. There are two rules that you need to remember. The first rule is that the size of a structure should be the multiple of multiple of the size of the maximum data type. Okay, the size of a structure should be the multiple of the size of the maximum data type that are there among the structure element. So here the maximum, the largest data type is integer, which takes 4 byte. Okay, so it should be the multiple of 4. And the second rule is that the way variables are stored in the memory is like this, that the variable that takes n byte will always be stored in memory location that is multiple of n. Okay, remember this very carefully. A variable that takes n bytes will always be stored in memory location that are multiple of n. So for example, integer takes 4 bytes. That means integer should always be stored in memory location that starts with an address that is a multiple of n, a multiple of 4. Okay. A short takes 2 byte. That means it should always be stored in addresses that is multiple of 2. Character takes 1 byte, so it can be stored at any place. Okay, clear to everyone? So let's see what's happening. So let me print the addresses. Okay. So the addresses of X, Y, and Z percent %p, percent %p, percent. So I can write %r1 dot x, %r1 dot y, %r1 dot z. All right. Okay, so let's see. So the addresses are like this: B060, B062, and B064. Okay, so let's see what's happening in the namespace. Okay, so the first element is a character. That means first one byte will be for character. Okay, so the first one byte is stored in 60. Just let me write the last 2 digits. The first or the character is stored in 60. Okay, so the next one, the next address is going to be 61, right? So what did I say? Short takes 2 byte. That means short will always be stored in memory location that are multiple of 2. Okay, so this 61 is not a multiple of 2. All right, so is short cannot be stored in this location. Okay, that's how short is stored in 62. So short will be stored in this address. So short will take 2 byte. So short is going to be stored over here. 62 and 63 is going to store the short. Clear? And after that, integer, the integer is stored in 64. Okay, so the integer is going to be stored in 64, and from here it will take 4 byte. Okay, so total 1, 2, 3, 4, 5, 6, 7, 8. So the total of 8 bytes are going to be allocated corresponding to R. That's how it is showing that size is 8 byte. Now it's not like if I interchange the order, size will remain the same. Okay, so let's suppose I am saying that this is an int and this is a short. Okay, character int short. The total size are supposed to be identical. But if I run it, the size of R1 is going to be 12 byte as opposed to 8 byte. Okay, previously also I had 1 character, 1 int, and 1 short. Now also I have 1 character, 1 int, and 1 short. But I just changed the order. And now it is taking 12 bytes. So let's see what's happening. Okay, let's go with the addresses. So first byte will be occupied by the char. Okay, first byte is occupied by the char, and the corresponding address is 7C. Okay, all right. Next, I need to store an integer. Okay, so here it is showing that integer is starting from 80. Why? Because 7D is not a multiple of 4. 7E is not a multiple of 4. 7F is not a multiple of 4. So the next address that is a multiple of 4 is 80. That's how integer is starting from here. Okay, so from here 1, 2, 3, 4, 4 bytes are going to be allocated for the integer. Okay, now so 80, 81, 82, and 83. All right. Next, the short needs to be stored. So the short is getting stored at 84. So 84 is a multiple of 2. So you can store short over here. Okay. So in total, it is taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as I said that uh, the size needs to be a multiple of the size of the maximum data type. So it needs to be a multiple of integer. Okay. So that means these two spaces are also going to be allocated. Okay. So total of 12 bytes are going to be allocated corresponding to this structure, this structure variable. Okay. So this property is used because this helps the memory read operation, okay, which is I'm not going to cover in this class. So if you store this structured element in this fashion, it directly improves the memory read operation. All right. So these spaces where you are basically keeping as blank or some junk value, these are called structure padding. Okay, this property is called structure padding because you are keeping these spaces blank. Okay, this property is called structure padding. Structure padding takes more memory, but it helps memory read efficiency. All right. So suppose I make it long. What will happen? Well, we have to take 16 byte. Why? Because character is taking 1 byte, so it is starting at 80. Character will take 1 byte. Next, the integer is starting at 84. Why? Because 81, 82, 83 are not going to be occupied by integer because they are not multiple of 4. Next, 4 bytes will be occupied by the integers. Okay. So 84, 85, 86, 87. Next, the long can start at 88 because it is a multiple of 8. So from 88, it is going to take 8 byte. 1, 2, 3, 4, 5, 6. So for long, it is going to take 8 byte. Okay. So total of 8 plus 4, 12, 13, 14, 15, 16. So total of 16 byte is taken. Okay. So these two rules you always need to remember when it comes to calculate the size of a structure, because size of a structure is not the summation of all the sizes. Summation of all the sizes plus the sizes that are wasted due to padding. Okay. And structure padding is very important property. It takes more memory, but it improves the memory read efficiency. Okay. There is another concept called union, which is also consists of multiple different data types. Okay, structure and union are exactly the same. There's only very few differences. So let's copy this function or this program and just paste it. And let's only change from structure to union. Okay. And then let's run it. So union. So it is going to run perfectly. Okay. So structure and union are exactly the same. Structure also consists of multiple different data types. Union also consists of multiple different types of data types. Okay, there is a very small difference. If you look at the size of function, the size of R1, it is showing 8 byte as opposed to 16 byte in case of a structure. Okay, union is only showing 8 bytes. Not only that, the addresses of X, Y, and Z are all identical. You will see X, Y, and Z are all identical. So what's happening? The union and structure differs in the way the variables or structure members are stored in the memory. Okay. So structure gives different memory for different structure elements. All right. Structure gives different memory for different structure. We give this memory for the character, this memory for the integer, and this memory for the long. All right. So structure gives different memory for different structure elements. Union doesn't give different memory for different structure elements. Union will give you a shared space. Okay, a shared space that is sufficient to store any one of these three variables. Okay, so it is going to give you a shared space that is equal to the size of the maximum data type, which is long. Yeah, long takes 8 bytes. That's how the size of the union is 8. Okay, so what happens is that union is going to provide you the size that is sufficient to store the maximum data type, and that space needs to be shared by all the three variables. Okay, clear to everyone? So union is going to give you a shared memory space that needs to be shared by all three members, and at any particular instance only one member can use the memory. Okay, so if I quickly show this, so in case of a structure, it is going to assign one space for integer, another space for long, another space for the character. Okay, including padding. So it is going to assign different space for different structure members. Okay, union is going to assign one memory that is long enough to store, that is sufficient enough to store the long, because long is takes the maximum amount of memory among these three data types. Okay, and this space needs to be shared by all three members. Okay, clear to everyone the difference between structure and union? Okay, so in union, at any particular instance, you cannot use more than one data type. That's the overall idea. So let me conclude it just by using one simple example. Suppose you have written r1.cat equal to c, sorry, r1.x equal to c, r1.y equal to 10, and r1.z equal to 100. Okay. So if you print %c, %d, and %ld, r1.x, r1.y, and r1.z. Print and run, you will see that the last one, 100, is printed correctly. The previous two has been corrupted. Okay, why? Because as I said that it will provide you a shared memory. So first, whenever you have written C, the shared memory is written with C. Next, whenever you are writing 10, the shared memory is occupied by 10. Last, you are writing r1.z equal to 100. That means the shared memory is occupied by 100. So now if you print x, y, and z, the last one is going to be printed correctly. Previous spaces are not going to be printed correctly, because it is going to provide you a shared memory. Okay, so the last variable that you have stored is going to be printed correctly. All the previous values are going to be replaced. Okay, clear to everyone? So difference between structure and union is that this is not going to happen in the structure. If you so here the values are going to be printed correctly as opposed to the case of union, because it gives different memory for r1, x, y, and z. So you can access all these three elements together But in case of union, you cannot access all these three elements together. At in particular instance, you can access one of them. Okay. So the situations where you need a shared memory, and at any particular instance, you cannot, you will not use more than one member. In that case, you can use union. But if you want to use a general scenario where different, you will access all the different members together, then you need to use structure. So structure takes more memory as compared to the union. All right, but union is more space efficient, but it is limited based on its usage.